Alright, so this is November 5th, 2020. We skipped 7.3, it was secant and powers of secant, and we don't need to do that, so we're skipping that. So now we're on to 7.4, which is on page 20 of the BC section. And again, we're looking at ways to deal with integrals. And basically down here, when we have this situation, maybe you're thinking we could possibly use a u substitution on that, but then your du would be negative 2x, and we have an x squared. So u substitution is not going to work here. But when they fall into this pattern of a square root with the sum or difference of two squares, then we can use trig substitution. Okay? So basically, we have these three situations, and all three of them kind of connect to the Pythagorean theorem. So if you think about it, if we solve for one of these sides, if we square root both sides here, we would get the square root of a squared plus b squared, which kind of matches this. So that's what we're going to use to do this. So here, that's going to be our hypotenuse. So our hypotenuse is going to be A, and this side over here is going to be U, which you usually have X, actually X's. But so if we do the Pythagorean identity on that, if we do whatever this side is, this side squared plus this side squared equals that side squared. So if we're solving for this, we can subtract that to the other side and then square root both sides. So this side would be a squared minus u squared. And we're going to look at this angle here. And we can use that angle to set up sine, cosine, whatever, and then we could substitute out whatever we need to. So I could write that below here, but I think we'll just see what happens with a problem. Or I could do a couple. Sine of theta is sine is opposite over adjacent, so that's u over a. So if we multiply by a, we get sine theta equals u, which is what they told us here. And we could do cosine and whatever we need to do. Okay, so if we move here, now, if that's the square root of that plus that squared, then that's u and that's a. So that squared plus that squared equals c squared. But then we take the square root of both sides to get that. So that's going to go there. And finally, down here on the end, what we're going to find is, so on this last one, u is going to be our hypotenuse. This side is going to be that. And this will be a here. Okay. So here, this squared plus this squared equals that squared. So if we subtract u squared minus a squared, then take the square root of both sides, we get that side. Okay. So let's see how this works on an example. Okay. So when we look at this, we have the number minus x. So that's the number u and x. U is kind of a substitution for x, depending on what that is. But here it's just straight u for x for u. So the hypotenuse is going to be 4. And then the opposite side is going to be x. And then this side is going to be, right, we'd have a squared plus b squared equals c squared. So subtract this over here and then square root both sides, square it. Subtract it over here and square root both sides. So that would be 16 minus x squared. Okay. So now we want to be able to substitute out some of this stuff. So we want to substitute this out. So we also want to know what x is. So that would be, if I want to know what x is, that would be sine. Sine of theta is x over 4. Sine of theta is x over 4. So x is actually equal to 4 sine theta. Okay, so now we can substitute that out. We also want to know what dx is, so we could do that right now. So we take the derivative of this, that would be cosine theta equals dx. Take the derivative of both sides. And so now we can deal with that, and we can square this and deal with that. So our last thing to deal with is this. That's going to be cosine. So the cosine of theta is adjacent over hypotenuse. And so that's going to be 4 cosine theta equals that. So what that's allowed us to do by drawing that triangle and look at the trig functions is now we can substitute out all three of those things. So if we look at the integral of that, we just said dx is 4 cosine theta d theta over this squared, that's going to be 16 sine squared. 16 sine squared theta, replacing the x with 4 sine theta and squaring it. And then that whole thing was 4 cosine theta. And that is 1. So the 1/16 we can factor out. And then we have 1 over sine squared, which is cosecant squared. Okay. Now the integral of cosecant would be what's the derivative of something that equals cosecant squared? So the derivative of tangent is secant squared, so the derivative of cotangent is cosecant squared. So that's going to be negative 1/16 cotangent plus c. Now if you go back to your triangle, cotangent, tangent is opposite over adjacent. So cotangent is going to be the reciprocal of that. So the reciprocal so tangent is opposite over adjacent. The reciprocal would be this over that. So that's going to be 16 minus x squared over, we've got the 16 from here, and then we got the x from there. All right. And miss that last step there. It's a little bit tricky because you'd be saying, well, why is this in this section? They told us that we were taking the square roots of things. But we can make an adjustment to this to turn it into a square root. So we can put 1 over the square root of x squared plus 4 squared. That would give us that squared. And now that'll allow us to come over here and work with our pattern there. So our hypotenuse, when we have a plus in the middle here, then that's going to be our hypotenuse. And our two sides are going to be, so this is going to be x, and this is going to be 2. So we square that, and we square that, and then we're trying to find c. C squared is equal to this squared plus this squared, and then you square root both sides. So we can make that substitution in there. Like that. Okay. So, what do we want to do here? We need to find out what x equals so we can find out what dx equals. So x, the easiest way to do x would be tangent. Trying to keep it as simple as possible. So the tangent of theta equals x over 2. So 2 tangent theta equals x. So we take the derivative of that. The derivative of tangent is secant squared. So secant squared, d theta equals dx. Alright. Now, to get this substituted out, the easiest thing to do would be to use the 2 in that. So that would be cosine. So the cosine of theta is going to be adjacent over hypotenuse. Okay? So I'm not really excited about this, but we could take the reciprocal. The reciprocal of cosine is secant. The reciprocal of that would be that, and so 2 secant theta equals this. So what we do is we just kind of play around with the triangle until we can find stuff that we can substitute out of there. So now we should be able to substitute out pretty much everything. So dx is equal to this. So we're going to have 2 secant squared theta d theta over, now this, which we rewrote in here, would be 2 secant. So if we square that, we get 4 secant squared. And if we square that, we get 16 secant to the 4th. Okay? Now if we reduce this, we're going to get 1/8, and we have 1 over secant squared. But 1 over secant squared, we can take the reciprocal of that, because the reciprocal of that's cosine. So we would have cosine squared, like so. Now, that goes back to that lesson we were doing with powers of cosine. We're going to want to switch that cosine matches. So it's 1 plus cosine of 2 theta over 2. So let's see. That would be 1/8, 1 plus cosine 2 theta over 2 d theta. Now, let's take, if we separate this, maybe we should factor out a 1/2. So that would be 1/16. We'd have 1 plus cosine 2 theta. So if we integrate, let's leave the 1/16. Where did I go over here? Over here, and there. So 1/16, and then the integral of 1 will be theta. Now the integral of this, we could use a u substitution. We also probably could figure it out. So we think about sine of 2 theta. The derivative of sine of 2 theta is cosine 2 theta times 2. So we don't have that 2 on there. So we're going to need a 1/2 to handle that. Okay, but sine of 2 theta is 2 sine theta cosine theta. So double angle, and then the 1/2 will cancel out with that. So we've got 1/16. times theta times sine theta cosine theta plus c. And now we need to substitute that stuff back out. All right? So if we wanted to solve for theta up here, theta, opposite, tangent of theta is x over 2. So theta is the arctangent of x over 2. So we can do that. So I still have a 1/16 here. And that's going to be the arctangent of x over 2. And then we have sine times cosine. So if you think about that, sine times cosine. Cosine's right here. Sine would be x over that. So I'm going to multiply this times the sine. And the sine is x over that. So if I multiply those two together, I'm going to get 2x over, and then when I multiply those together, the square root cancels out, so I have x squared plus 4. Alright, so when you have the variable minus the number, then that is going to go over here as the square root of 4x squared minus 1. Alright, so that means hypotenuse is going to be 2x, and then this side squared is going to be 1. Alright, because we would have a squared plus b squared equals c squared, so we would have that squared minus this squared equals this squared, and then we would take the square root of both sides. So hopefully you're okay with that. Now the easiest thing to do here would be to look, because we want to solve for dx, so we want to solve for x first. So this is cosine. So the cosine of theta is 1 over 2x. So if we multiply by x and divide by cosine, we'll get that x equals 1/2 secant. Okay, so dx equals the derivative of secant is secant tangent. Now, if we look at down here, with this 1 here, that's kind of nice. So opposite over j, that's tangent. So the tangent of theta, tangent of theta is that. So now we can pretty much substitute out that whole thing. So we have the integral dx is 1/2, so that 1/2 we can pull all the way out front here. Secant theta d theta, or we could put it on the side, secant tangent, sorry. Secant tangent, I'll just put the theta on the side. And then that's tangent, so we have that to the, so that, if we cube both sides, so if we cube this, we would get this. So that means that cubed, that'd be tangent cubed. This is this cubed. So this cubed goes here. Now, that'll cancel off with one of those. Now we have a secant and a tangent squared. So normally, in that scenario, you're going to, one of the techniques in dealing with trig functions is get them to all be the same thing, or switch them all to sines and cosines. So secant is 1 over cosine. And this was over tangent, so tangent squared. So if we want to take the reciprocal of that, that would be cotangent squared. So tangent is sine over cosine. So cotangent squared would be this. Now we can cancel that off with one of those, and then we can separate these signs. So we have 1 over sine, we have cosine over sine. Okay, so now that's cosecant and that's cotangent. We still have our d theta from there. So that actually matches one of our memorized, hopefully our memorized, is cosecant. The derivative of cosecant is negative cosecant cotangent. There's no negative there, so we're going to need one here. Alright. And then on these, we always need to substitute back. We need to switch back. So cosecant goes with sine. Sine would be this over this. So we need to take the reciprocal of that. So that would be this over this. The reciprocal of that would be 2x over this. And those 2's would cancel. Alright, and we'll do one more. So here, hypotenuse is going to be 2, and this side is going to be x. So I don't know if I need to do that after you guys. So if this was a, we'd have a squared plus b squared equals c squared. So we would subtract, so we'd have 4 minus x squared, and then we would take the square root of both sides, and that's where we'd get the 4 minus x squared. Okay, so we have an x, we want to get rid of that, we want to get rid of the dx, so let's find x first. So the easiest way to find x would be sine. Sine of theta is going to be x over 2, so x is 2 sine theta. And if we take the derivative of that, that's going to be 2 cosine theta equals that. Okay. Now, we also need to be able to substitute this, so the easiest way to do that would be cosine. So we have cosine of theta equals this over 2. And since we just have that, that means that's 2 cosine theta. Alright, so now we ought to be able to substitute things out, and this is a definite integral, so we want to be careful about that. So x squared is right here, so that's going to be 4 sine squared theta. And that is 2 cosine theta, and dx is 2 cosine theta d theta. Okay, and I need to think about those limits of integration there, so that's a little bit awkward. So if if x equals 0, we have the sine of theta equals 0, so that could be 0. And then if we have 1, the sine of theta equals 1/2, because x equals 1. So sine is the y-coordinate, and we want the y-coordinate to be short. So we want the y-coordinate to be 1/2. So that's at a 30-degree angle, which is pi over 6. Okay. Those are going to cancel. And we're going to use that cosine switch, sine squared, that's 1, and sine is minus. So we did one on the other side that was positive because it was cosine squared. cosine squared is positive, sine squared is negative here. And then we double the angle and half of that. So now if we place that in place of this, 4 times that would leave us 2. So we would have 2 times that. So that's going to be 2 minus 2 cosine 2 theta d theta, which should work out pretty nicely. So if we integrate that, it's going to be 2 theta. And if we integrate this, it's going to be sine 2 theta. You could do a u substitution, but hopefully you realize because of the chain rule, we're going to get that 2 from here. So that's actually pretty nice. That's about it there. And then we're going to plug in, so we have 2 times pi over 6. That's going to be pi over 3 minus, that's going to be pi over 6. So that's going to be the long y value. So that's going to be root 3 over 2. And then 0 minus sine of 0 is 0. So not much going on there. So there we go. All right. It's about that time.